Okay, this video is the discussion on how to test the normality of the data whenever we are going to analyze the data statistically. Because one of the assumptions in using the parametric test in the statistical analysis is to determine whether the behavior or characteristics of the data are normally distributed or not. Okay, so that is why we have to check if the data is normally distributed or not. So how do we do that? First, we are going to search as to how we will compute the test of normality. So we can search that in Google. We can type here test of normality, okay, using skewness. Okay, this is the simplest way of testing the normality of the data. And don't forget to write that PDF because we need that all the options given by Google are all PDF forms. So we can download that directly. Like this, you have here skewness test of normality. We will check if we can use this. Okay, so we are very thankful that we are provided with this manuscript published internationally. However, we still have to look for the simplest and we need the formula. So we'll try to explore another documents. So we'll try here. Okay, very good that we are directed to ResearchGate and then we have the option here, download full text PDF. So meaning we can get them documents freely. And this is from Hae Young Kim of Korea University. So we'll try to download it now. And then we are going to check whether we can use that. Okay, file. Okay, so we'll try now. We have here. Okay, so very good that we have here the file. Okay, so we are going to check whether we can use this. Okay, and then here, no, I appreciate we have here number 2. We are provided with a test, normality test using skewness and kurtosis. So let us read. A z-test is applied for normality test using skewness and kurtosis. A z-score could be obtained by dividing the skew values or z-kurtosis by their standard errors. And then we have the z, we have that value. However, we are provided here with the small samples and less than 50. So that means if the absolute z-scores for either skewness or kurtosis are larger than 1.96, which corresponds to an alpha level of 0.05, then reject the null hypothesis, meaning the data is not normally distributed when the value is greater than 1.96. For a medium-sized samples, if n is greater than 50 but less than 300, if the z value is over 3.29, that we can say the data is not normally distributed. However, for 300, we just look the skewness and kurtosis without considering z values. If the skew value is greater than 2 or absolute value larger than 7, for kurtosis, then the data is not normally distributed. So thank you very much for this. So we'll now try to analyze our data based on that concept. So let us say this is the data bank and we have here the parts. The first column is the respondent and we have 30 respondents actually. We have the gender, age, and civil status. We will not solve that now. What is important is to check whether the data is normally distributed on satisfaction, considering that in the satisfaction there are 10 questions. And we still have to get the total and the mean satisfaction. How do we do that? For the total, we have to do the Excel command equals sum open parenthesis and then highlight all the data that needs to be analyzed. Then close parenthesis, enter. To get the sum of all the respondents, so we have to find this cross sign and then double click. That's it. For the mean satisfaction, we have to use the command equals average, open parenthesis, highlight, okay, until S10 equals. Again, we have to use the plus sign, double click. Now, we still have to look for the motivation. We are given motivation level with 13 questions in this case for as an example. So we can use the sum command. Sum, open. Okay, highlight 2 to 13. I mean M1 to M13. Okay, double click. And then motivation is equals average from M1 to M13. Enter. Okay, very good. We are done with the motivation. Okay, so our target again is to test the normality, and we have to check the normality. The first thing we do is to find the skewness of satisfaction. Okay, so the first is we are going to use this command, home data. You look for data and find the data analysis. Okay, for data analysis, you find descriptive statistics and then input the range. So the range that we are going to analyze. So example here, we want to analyze the total satisfaction. Here and then labels, because I include the labels there. Then I want the data to be reflected here. So I just click here, make sure that that's AK6 is AK6, meaning we have to put the data there. And then check the summary and the confidence level at 95%. Then equals, so as you can see, we are now given with this data. And what we are looking is only the skewness. Okay, so anyway, skewness or kurtosis, we have different formulas, but then we can get already whether it's normally distributed or not using the skewness. However, we can also, we still have to get the skewness, I mean the standard error of skewness. We have standard error here, but this refers to the standard error of mean. This is not for skewness, so we will just compute later how to do that. And we still have to look for the descriptive of the total, the satisfaction, but this time not the total, but we are going to use the mean, the average. So this is for the comparison whether if we use the total, it's normally distributed or not versus the average. Okay, so let's try to put it here and then okay. And we can see now that in the total, okay, mean satisfaction, we have the skewness. Of course, they are almost the same. Try to look at, they're almost the same. However, okay, so I did not, okay. If you look at it, yeah, they are equal actually. So there's no question whether we will use the mean or the total. Okay, so because they will arrive the same answer. However, in some areas like standard error, there is an error. No, they are not the same because it matters in the values and the median and mode. Okay, so in the skewness, they are the same. So the next thing that we are going to analyze is now the skewness of the motivation. So again, we will use that data command. Go to data analysis and the descriptive. This time we will go to the motivation. So I think it will work when we will use the total alone. We will no longer use the average. Okay, so I will put that here. Okay, so that's it. So we have the skewness already here. That is for motivation. So good that we have total motivation and total satisfaction. Okay. So the next thing is we have to get the standard error of skewness. And how do we check? How do we know the standard error of skewness? We have the formula, and the formula matters on the sample size. So the formula for the standard error of skewness, we have to determine that the standard error of skewness can be computed using the Excel or using the formula. Okay, so that is square root. We can have here the square root is equals is square root. Okay, I will just write here square root open parenthesis of 6n close parenthesis times n minus 1. Okay, close parenthesis over, we have n minus 2 times n plus 1, then times n plus 3, close parenthesis. So as we notice here, it's a square root, so it has to be inside all the parentheses. However, there is division sign, so we have to ensure that there is numerator. So we put that first in the parentheses. Okay, and then divisor, we put this also in the parentheses. there. And then if you look at it, we still have to put that in a parenthesis for that square root there. Okay, so that's the formula. However, if we are going to put the formula here using now the equal sign, okay, so equals. So as you notice, the color changes here. So that means the red shows that 6n times n minus 1 should be completed first. No, that is the numerator. And the red here is the denominator. And then we have last parenthesis that we have to divide first, then we will get the square root after. And that's the formula. Now, in application to this example, we will change n into the number of respondents. Okay, so we can use the asterisk to say multiply, and there are 30 respondents actually. And our n is again is 30. We will change n into the number of respondents used in our analysis. So if we will replace that n into numbers, then of course we can get the value already. We'll put enter, and then that is already the skewness, the standard error of skewness. Okay, now let's use that idea here. Anyway, our motivation, we also have the same number of respondents used. And if you notice, our formula for skewness matters most on the number of respondents. So the same skewness for both motivation and for satisfaction. So by formula, as mentioned by our source a while ago, so we have to use the z-score, which is the value of the skewness, which is the skewness divided by, okay, so I'll just have it equals the skewness divided by the skewness standard error of skewness. We have that. And that is the z-score for the satisfaction. Now we are going to get the z-score for motivation. So again, we divide the skewness by the standard error of skewness there. And this is our new z-score. So as mentioned a while ago in the work of our reference, since it falls on n less than 1, n less than 30, therefore, we have to take note that the absolute value should be greater than 1.96. So we can claim it's not normally distributed. And in here, the absolute value can be less than 1.96, and this is also less than 1.96. So in this case, we can claim that the satisfaction and the motivation level are all normally distributed. So that is how we will try to analyze whether the data is normally distributed or not. Now, in this case, it's normally distributed. Therefore, we can now use the parametric test. For that, normality test is already complied.